So before we move on to ports and our different protocols that work with different port numbers, we need to understand that there are some protocols which don't work with port numbers. They're like our TCP and UDP and our routing protocols. There are some protocols that don't really have port numbers. Now, as we'll talk about in a little bit, we have some of our protocols that work with port numbers, and these protocols work with port numbers because they need to know where to deliver information. Port numbers are essentially an IP address plus an additional number, and that additional number allows us to have, sort of like how a country has multiple different ports, it allows our computer to manage multiple different data streams at one time. So those data streams still have to have a place to go. They have to have a logical place to send data to that's consistent every single time. So we know that this data corresponds with this particular activity. And that's what our ports do. Our ports allow us to receive different data streams from different protocols. But there are some protocols that don't work with ports because of the layer that they work on. And these are our network and data link layer protocols, or TCP/IP suite network and data link layer protocols. Now, we brought back up our chart, and what's our network layer and our data link layer? Well, our network layer and our data link layer of our OSI model are right here and right here. There are layer 2 and our layer 3. We have our OSI model, a seven layer ideological model of how a network works together in the form of layers. And we have physical layer, which is 1. Please do not throw sausage pizza away. Physical, data link, network, transport, session, presentation, and application. These protocols work either on the network layer or the data link layer. The data link layer protocols especially won't have port numbers because they're not going to necessarily be communicating via an IP address. And you need to have an IP address to have a port number. Port numbers are identified as IP address : port number. So you don't have that IP address, where does that port number go to? Which of the millions, billions of IP addresses does this port number correspond with? So that's not going to help us. Our networking protocols, some of our networking protocols don't use port numbers either because there's not a particular port that they could deliver to in this case. They just need to deliver a message or attempt to deliver some sort of information. So we use these different protocols. So we have ICMP, IGMP, and ARP. ICMP and IGMP are going to be on our network layer. They're going to be network protocols. And ARP is, we're going to put under our data link, but it's really sort of like a layer 2.5 almost, because it's going to negotiate between networking and data link layer. So now that I've gone on enough about why these are special protocols, let's actually talk about what they do. ICMP stands for Internet Control Message Protocol. And what ICMP does is it allows us to deliver errors and queries to other particular IP addresses to determine if a service is available or to determine if there's some sort of error going on. You'll see ICMP messages in ping requests. A ping is simply an ICMP echo request to a particular target. So an ICMP protocol, when you think about it, doesn't really transmit data. It's really just a packet with information. So when you think of data packets, we think of packets that transfer things like files or emails or web pages. And then you have other packets which are just message protocol packets. In this case, our ICMP packet. So if we send an ICMP echo request packet, what we're doing is we're essentially sending a message to a target computer saying, can you hear me? Can you see me? Now, if that other side can see us, it's going to send an echo request back. Now, we can format certain routers, we can format certain servers not to respond to these, because maybe we don't want somebody to know if it's there. Maybe we don't want someone enumerating our network or enumerating our router, so we don't want them to allow ICMP echo requests back. Maybe we don't want someone trying to run a denial of service attack on our router by sending millions of ICMP requests to that one router, because responding to an ICMP request does take network bandwidth, and it does take a little bit of computing power. But if it has to do that to millions of different locations, it's going to take all of our network computing power and all of our bandwidth, and we can't service our clients. So sometimes we will disable ICMP messages back. So just because you're not getting an echo request back doesn't necessarily mean that object isn't online. So our ICMP requests, Internet Control Message Protocol, it's going to be a network layer protocol. It's not going to have a port number associated with it, and it's going to help us to deliver error messages and query messages. ICMP we're going to use for things such as our ping requests, our trace route requests, our different requests to devices to see if a service is available, to see if a particular device is up. So we have our ICMPs, and we'll just remember that a ping is an ICMP echo request. We're requesting an echo back, letting us know if this device is online. So, exam question: which network protocol does a ping request use? Does it use ARP? Does it use ICMP? Does it use HTTP? Or does it use SQL? And our answer would be, ding, 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 ICMP. Because a ping request is an ICMP echo request. Now, next we have IGMP. IGMP stands for Internet Group Management Protocol. And IGMP is going to be, we don't even have it up here, it's going to be multicast membership. So, Internet Group Management, we've talked about how multicast is one too many, and we need a way to manage those multicast members, and we need a way to manage membership in multicast addresses. Remember, a multicast address is an IP address that we send a message to, and that message goes to multiple different locations, multiple different computers. IGMP manages those different addresses, manages how those messages go out to those different computers.